here.
Yep.
Okay, we can hear you well.
Yay.
Welcome to Astro Cafe for Monday, May 13th. I have 3 people on my list for subject matter tonight. David Lee for Aurora Images, Randy, Geomagnetic Field Information, and Dorothy has an invitation that she would like to extend. Is there anyone else who has something to share?
I could share some pictures I've got as well.
Rock.
Is there room for?
Oh yeah, no, we have Nathan, of course.
Oh,
We have Nathan, as in Nathan live, or Nathan, we're speaking about Nathan.
No, here he is.
Yes, we can't see him. I can't see him.
Oh, there he is.
There's Nathan. Hi, Nathan.
Ed, why don't we change with Nathan, then you'll be able to.
I'm not
Sure.
sure how to share.
Right, Ryan screen, sorry.
Yeah, Nathan.
All right.
Right.
Oh, here's Nathan. It's right in front of me.
There we go.
I appear phantom like a quantum fluctuation.
No.
All right. Is there anyone else who has something to share? All right. So,
could I just say, Alex, the camera is pointing quite a bit to the left.
Oh.
It could be inched
True.
over a little bit and get a few more people.
there we go.
That, perfect.
Lovely.
Yay. It's a full house here.
It is.
It is.
Should we bring more chairs?
We might need.
Lord, we're okay.
I can see Brenda back there.
You got your chairs and stuff.
There.
Yeah.
Yep.
All right.
All righty. So shall we start with Nathan?
Sure. I might have some difficulties getting on the Zoom or sharing my screen. Other than that, because like no Wi-Fi here. Is there?
There's excellent Wi-Fi here.
Oh, fantastic.
Yeah, it's so don't pick Nathan first, and Nathan, it's written on the board over there.
Awesome.
All right. So Nathan is not first. Is that the
Yeah,
conclusion?
I'm gonna go over to get the password over there.
Right. Nathan is not first. All right. So David, let's begin with you.
All right. I'm probably not going to say too much except initiate a few things. I noticed there's been a fair bit of banter on email about the different kinds of aurora. So I thought it might be good to just share, especially for people that are not that familiar with the phenomenon. We could sort of share a little bit of knowledge about that. Now, I've been busy making videos, so I haven't really had a lot of time to prepare anything formally. So I've got a bunch of my tools up. I've got Photoshop up, and I've got my video thing up. So I'll just show you some of the almost finished, but kind of exploratory kind of material. So anyways, let me just share. So I'm going to start by asking how many people actually saw Aurora?
Me.
I think almost everybody did, right? Yeah, almost everybody did. Anyways, in the middle of the week on Wednesday, I was trying to find an image of the sun so that we could maybe work on a video for solar observing for Astronomy Day. And that's when I saw this humongous sunspot. This is AR, I think 3664. In fact, it may have had a companion that was close to it. I sort of remember 2 numbers, but I think 64 and maybe 65 perhaps. But you can see how big it actually is. It's huge, right? And in fact, I saw it again. I guess it must have been last night. I saw it again. And it's right on the edge now. It had made its way over to here in that course of time. Anyways, so sunspots are kind of cooler spots on the sun, but they have this characteristic that they can create coronal mass ejections and solar flares, which kind of go out into the universe and often head towards us here on Earth. And hopefully Randy will explain a little bit more about the magnetic field of the Earth, because I'm not an authority on that. But as that radiation reaches Earth, there's a part of the atmosphere which is, I think it's the ionosphere or something like that. Anyways, there's molecules out there that get excited by this radiation, and their energy levels go up. And as they try to come back to stasis, they gain energy, but they have to come back down again. And when they come back down, they give off photons. And depending, there's really two main kind of molecules that are excitable. I mean, hydrogen as well, but it's mainly oxygen and nitrogen. And you can probably tell from these images, the green stuff is oxygen, of course, and the kind of bluey violet kind of areas are nitrogen. Now, I also understand, I just read this recently, that another reddish hue that's underneath of a green band could be hydrogen as well. So I was surprised. I knew there was Aurora. In fact, I was almost only half aware of Aurora when I left on Friday night to join some people for ETU group. So Jill said that at least some people were going to Cattle Point instead of Pearson, and they may regret it now, I guess. When I arrived, there was cars double and triple parked, and I went around at least 3 to 4 times, wasted my gas, then found out that I was running on fumes, so I had to skedaddle out of there. Yeah, there obviously people were kind of joining the Aurora mania, which I'm sure was fueled by the press. So I did get some gas, and I headed out to the gates of the DAO, which was pretty dark actually. So this is where I caught these images, and these actually are done with my phone. In fact, I found that the iPhone was a great resource for just seeing the shape and the movement in general, because it was enough of an amplifier to actually literally see this. And the other thing I want to mention is this is the first Aurora that I just didn't get a hint of. I visually saw it. And in fact, it was so bright that when I went back home to my light polluted suburbs, I could still see them. So this was exceedingly bright. It took on many, many different patterns, but the one that got me the most amazed by was this coronal pattern, which when I pointed pointed the phone and my camera upwards, I had this kind of vortex, almost I don't know, event horizon kind of effect display. And I'm sure many of you got that as well. But I remember Jeff Pignet remarking that he saw mostly curtains, which would be more of this nature right here. Now, I advise you all to look at this reference. This is the Sky at Night magazine reference, and it describes all that there is to know about color and shapes of Aurora. So I've already mentioned these color things that are caused by certain molecules, and these are the shapes that they talk about. Now, I didn't have time to prepare this, so I'm just going to show you some pictures. These are captured from their website. Again, I acknowledge Sky at Night for this material. So bands, patches, corona, which is what I saw, and sort of like rays, but mostly this, I would think. And I think these are arcs, I think, and those are the main categories or main types. Now, Jeff asked me how common this this radio or this corona type shape was. 24 years ago at Island View Beach, I actually photographed an aurora which was very similar to this, and it actually reached from the north horizon line to the east horizon line and formed an arch. So it wasn't so much like a coronal pattern, but more of like an arch, but very similar in this kind of patterning.
What year was that?
August 2000. it's still on a Belgium site, believe it or not. Yeah, if I can locate it, I can show it later. So those are the main types. I don't know. I'd be curious. Did anybody see anything other than the corona type pattern?
Oh, I saw rays.
Yeah, rays. Yeah, but did anybody see like curtains?
I saw curtains.
Okay. So they say, I've read a couple of articles now, they say that the pattern the corona pattern is very common in very strong activity. And they also say that variation in what it looks like is a matter of perspective. So it really depends on where you are on Earth. You may see a different kind of pattern. The other thing that I really enjoyed about the Aurora was that it was very gossamer, like you could actually see through it. Like it wasn't solid color. Now, for the people that had a lot of saturation in their photos, they may have missed that. But I actually love seeing the stars through the Aurora. So I try not to overdo it very much.
David,
yes.
What time were you taking those pictures?
This one here happened at 10:53. That's what the metadata says. And that's at the gates of the DAO. It was very, very strong. When I arrived, there really wasn't much, and I just kind of waited. But all of a sudden, it all broke loose, and it didn't stop until, well, I stayed up until about 2 in the morning. So anyways, I don't really need to say much more. I just wanted to share what I had. I'm pleased that I use both my iPhone and my regular camera. I'm just as happy with my iPhone pics as I am with my better camera. They're just different. They're not as sharp. Like the foreground objects are not as sharp with the iPhone, but just for the sheer ability to capture it and also to have that preview effect, to literally see it in the phone was amazing. So I'm sure other people have things to share. So maybe we can go around and collectively show what we've seen as well.
If I can make a comment. When you see a corona and you see it apparently having rays, that's because they in fact are rays, and you see them converging to make the corona type of feature because you're underneath them, and they are in fact converging by perspective overhead.
Right. That makes sense. Actually, that makes sense.
That's what corona actually is.
Yeah. Oh, actually, before I finish, I'll show you one more thing. Let's see. Get rid of this. A tip to people that want to take a video of the Aurora, don't bother because it uses with video, you're using a 60th of a second basically, which is 2 times the frame rate, which is what you're supposed to do, right? So with that, you don't really get enough exposure. So you kind of need to do time lapse instead. And then you could do like, I don't know, like 4-second or 8-second exposures, and then just stagger them. And then you can just stitch them together and have a similar kind of effect. You would have done that anyways with a video. So much superior. And this was amazing. I just love this kind of searchlight effect. It was very theatrical. The dark trees play the role really, really well. And yeah, I was happy with it. Anyways, that's mine.
The stars
Very
in the
nice.
background were dancing around back and forth, which was fun.
Oh, they were moving. That's because
Yeah.
I was overtime, right?
Well,
Yeah.
back and forth, back and forth.
That was fantastic, David. Thanks.
Well, thank you.
Thanks for sharing those. That was wonderful. I've never seen an aurora like that.
Did you see it in Mill Bay?
No, I was looking at the inside of my eyelids.
Oh.
I had a long day that day, and
Oh yeah. I'm glad I didn't miss it. So
Dave, do you want to question?
Yeah, as a guy who's quite familiar with Aurora, having come from Edmonton, where we got Aurora on a very common base. This is the second best I have ever seen.
Oh,
Even coming from an Aurora country, a region, or
Quite familiar with the coronal aurora. We get that, once or twice a year in Edmonton. We'd get Aurora south of Edmonton. Sometimes you can see it in the southern sky. And sometimes we'd see Aurora bright enough you could read a newspaper by it. The brightest aurora I
go
ever
ahead.
saw, the brightest aurora I saw was way back. My wife and I were coming home from a ski trip in Jasper, and we were about Edson, and the whole sky went red. And we thought it was the well blowout that was
Oh,
something
dear.
there. So we stopped the car and got out, and we looked around, and oh no, the whole sky was red. Well, that was the night that the power went off all of eastern seaboard in Quebec and New York.
1989.
1989, yeah.
All
That's
right.
Oh,
the
yeah.
strongest I've ever seen. But this one is second by far. We went to went to Telegraph Cove. We tried to get to where a lot of people were going at the Star Park, but you couldn't get there. There were cars going on the beach drive. So
it was impossible. Yeah.
And the nice thing with Telegraph Cove was that it faces almost due north, and you could see that clear arch of where the aurora ended, and it was bright enough that you couldn't see the dipper, so I couldn't get quite true north. But I had north on my compass, and I could see where the magnetic deviation was, because the center of that arc was the same degree off due north that you the magnetic pole would be.
Fantastic.
That was a lot of fun.
That is really good.
Thank you very much, David. When
You're welcome.
I was in St. Thomas, Ontario, and I thought, oh no. And the photographs were just incredible, of course. And we were having rain and overcast. So nothing there. Thank you.
Marjie, if I may. For those of you who attended Dennis Crabtree's lecture on Wednesday night, or more so if you didn't, I have prepared the video from it. I have it in its entirety, and I also embedded the slides in with the lecture, because when you videotape it, you don't really see the screen that great. So what I did was I got Dennis's PowerPoint deck, and I interleaved his slide deck with the video. So the sound is really good. The only thing I don't have is, and I'm going to work on it, is that he had a guest who is very cognizant of the early days of the Hill, and he had some remarkable stories, but unfortunately the audio is poor because I think he may have held the mic too close and he was handling it, which causes kind of rustling sounds. But I think I can retrieve it from my other mic. I have to work on it to get it back, because I would hate to lose it, because the stories are just amazing. So the first release is available. It should be available tomorrow. I'm going to get that to Joe to post. I'm putting it up on Vimeo tonight. I think Reg, you said that you would test drive it for me to make sure it's okay. And then we'll. I haven't done it yet because I haven't loaded it up. It's 6 gigabytes, so it's kind of big. So once I get it onto Vimeo, it'll run fine. So yeah. So go ahead.
I was just gonna say, can you tell me what that name was of the of all the things about the error, or the what we were just talking about?
You mean the Aurora, or?
Yeah, Aurora, yes.
Oh yeah, I'll put the link to the material in the chat. It's actually from an article that BBC Sky at Night produced. It's very good, actually.
Okay.
So I'll just put it in the chat here.
Okay, that's great.
There you go.
Excellent.
All right. See if this works. Okay, fantastic. So, previously, how to have a perfect scientific existential crisis. Now, our place in the epic story of the universe. And the sort of mindset that I want to get everyone in before I begin, it's something that I begin with in the preface, is the sort of magnitude of everything that's happening in the universe. If you were here at my Bull and Books book launch, I did this little exercise with the audience where I had like a yoga breath, 3 seconds in and 3 seconds out. So while you're doing a yoga breath, like 3 seconds in, 3 seconds out, here are just some stats about everything that happens in the span of 6 seconds during a yoga breath. So this is like the sort of existential and crisis inducing content that you will have to face if you dare pick up the book. But this is the sort of stuff I love as well. And so the sort of things that I wanted to dive into in this project were kind of 4 fundamental questions about our place in the universe. So where are we in the universe? Where are we from? Where are we going? And are we alone? And I wanted to start with, are we alone? Because it is just such a tantalizing, fascinating question that I believe has perplexed our civilization since the dawn of humanity. And so to begin, we live on a planet that likely evolved life at the bottom of the oceans with extremely basic carbon-based genetics. And that has been the case throughout the entire history of life on Earth. It has been carbon-based mixed in with water. So carbon and water, I think no one will object to me saying that those are like the holy grails of life on Earth. There is not a single organism alive today that does not utilize some form of carbon and water. And turns out they're pretty good at building life, because carbon forms 4 valence bonds, which is the highest that any organic sort of element can form. Nitrogen's 3, oxygen's 2, hydrogen's just 1. And water is a great medium for all this stuff to flow in. So it's no surprise it's pretty great. It's also no surprise, therefore, that in our search for extraterrestrial life, we have almost entirely made this search about water carbon planets, like Mars, like Europa and Enceladus, the moons with underwater oceans filled with water and carbon. And it turns out we found these watery worlds basically everywhere. Uranus has 4 large moons that may have underground ice water oceans. Pluto may have underground ice. Ceres, the asteroid, may have underground ice water. Mars, well, we already know it does have ice water on it. And because of how unbelievably common water and carbon are, even in our own solar system, it seems strange that we found nothing yet. As a matter of fact, it's not just on the surface, but a while back we had this like excitement about Venus and the phosphine gas in Venus's atmosphere. That turned out to be a little less promising than it seemed, but phosphine is a molecule that is almost always produced by microbes. And in planets that are gaseous, because Venus has an extremely thick atmosphere, but Jupiter, Saturn all have traces of water vapor in their atmosphere. And when you have gas giants, there's like this transition zone from gas to sort of a more liquid layer, which is different from the Earth, because the Earth has like a liquid ocean and then a pretty obvious switch to air once you rise above the ocean. But for gas giants, it's sort of just this blend. And while we've never found anything, Carl Sagan in the 1990s imagined life forms that evolved in the liquid layers of a gas giant and then rose up into the upper atmosphere. And as a matter of fact, there are so many planets throughout the galaxy that have underground oceans that if you keep them warm enough, you can even keep underground oceans as a planet is ejected from its solar system, something called a rogue planet. These are planets that have been kicked out of their star systems and are left drifting through the cold void of empty space. You could sustain underground oceans with a thick enough atmosphere. So if life evolved in these underground oceans with a layer of rock or ice, they would probably spend their entire existence believing that that region of ocean is their entire observable universe. Like, talk about sad. It's like, just like feel the wall and there's like, the edge of the observable universe, nothing beyond it, obviously. But is water and carbon really the best we can do? Because when you think about how chemistry works, I have a couple molecules listed. Obviously, we're familiar with water, which is the one in the upper left, and methane, which is in the upper right, and carbon dioxide, which is the bottom right. But there are other molecules that bond in the same patterns, have the same bonding patterns, have the same sort of chemistry. Like the other 2 molecules listed under water so H2O is water. What's below is H2S, so sulfur, and H2Se, which is selenium. Those both form liquid-like substances that behave similarly to water. Similarly, what's it called? Silane is the the silicone equivalent of methane. It is also a gas. It also behaves similarly to methane. So when you think about the fact that different molecules could produce similar chemistry, then when we look at Titan, which is minus 180 degrees Celsius, but is prolifically filled with methane and nitrogen, which is liquid at the temperatures of Titan, could you have life forms that use methane and nitrogen rather than carbon and water? I have two vials, and a rock with me here today. This is methane gas. This is water. This is a rock made of silicone. And I have these here today because these are all very similar molecules, just at drastically different temperatures. Methane is liquid at the temperatures of Titan, minus 180 degrees Celsius, but it's a gas here on Earth, so you wouldn't really imagine anything living with this stuff. Water is a liquid here on Earth. Obviously, we find life in it, but on methane, it is so hard that it's basically a rock. This is what water would be like on methane. If
Titan.
Oh, right, on Titan, thank you.
You're paying attention.
On the opposite end of the spectrum, on a molten planet, this rock of silicone becomes liquid like water, and water boils to become a gas like methane. And so silicone, even though it forms rocks here on Earth, has exciting chemistry at temperatures of thousands of degrees, just like methane and carbon do here on Earth. And so I like to imagine this thought experiment that on a molten planet, or even deep within the Earth's mantle, where there is tons of silicone and molten temperatures, could you have something where there's liquid silicone and little silicone organisms swimming in this shadow biosphere right beneath our feet, and they have no idea that we exist just above their heads? Obviously, that's borderline science fiction, but that just goes to show there could be a staggering range of possibilities for life out there. The second thing that I want to talk about is where we are. We are in the middle of an incredible universe that appears to go on forever in all directions, because it probably does, based on recent scientific theories. And the concept of where we are is a strange one, because we're moving at 600 kilometers a second. So in the time I've been giving this presentation, we've already moved twice the distance to the moon and back through the universe. But to talk about where we are, I think it's nice to talk about the fastest thing in the universe, which is light. And it takes light about 5 hours to cross the inner solar system. But on the scale of a galaxy, it actually takes 100,000 years to cross the Milky Way. And you know how the further out in space you look, the further back in time you look, because it takes longer for light to reach you? Well, human civilization's only been around for 12,500 years, and the galaxy's 100,000 light years across. So that little bubble there is everything in the universe that could ever possibly know of our existence, because anything beyond that hasn't been enough time yet. So in terms of us ever hoping to contact anyone, or anyone ever knowing about us, I don't know if we need to worry about that, because this is all we've influenced so far in the entire history of humanity. And the Milky Way is just one of several dozen galaxies in the local group, which is one of several dozen groups in the Laniakea supercluster, which is one of 10 million superclusters in the observable universe, with a radius of 46.5 billion light years. But keep in mind, the observable universe is just an optical illusion, because it takes that long for light from the beginning of time to reach us. That is by no means the edge of the actual universe. And when you map it out, the galaxies on the edge of our observable universe actually see their own observable universe, complete with a whole region that is beyond anything we could ever hope to see. So how big is the whole universe? Could be infinite, and current theories actually predict it is infinite. And something I mentioned at Bowl and Books is when you get into the matter of infinities, then it becomes inevitable that there's infinite amounts of everything, including copies of this room and me giving this presentation infinitely many times and a whole bunch of weird stuff. But that's the sort of existential crisis stuff that my original subtitle was supposed to live up to.
Do you sleep?
I do sleep a staggeringly low amount, because I'm kept up at night by these thoughts, but I do sleep.
Exactly.
But I do sleep, believe it or not.
Okay.
It's the sort of the existential wonder you get from lying in bed at night, lying under the blankets, like wrapped up cozy, staring up at the beautiful night sky, pondering the deep questions like, are we alone in the universe, and what the heck happened to the roof? And the other things. But so in terms of where are we from, I prefaced with this at Bowling Books. Where do babies come from is the deepest question I believe we can possibly ask. Because when you extrapolate that beyond the parents, beyond the grandparents, all the way back to the beginning of time itself, it becomes a matter of the history of the entire universe. But where do babies come from? Really, the Big Bang, if you take the innuendo. But when you map the dawn of life back to its origin, if you take all the atoms in your body and you dial back the clocks, where would you find those atoms? Because if you actually go more than 7 years in the past, you'll find that not a single atom in your current body was in your body more than 7 years ago, because our bodies are just recycling themselves that fast. 100 years ago, most of your atoms were actually evenly distributed around the planet, as it turns out. So this sort of packet of atoms that you are currently is a very recent thing. When you go 4.5 billion years ago, right back to the birth of the Earth, your atoms were kind of more or less distributed throughout the Earth's crust, deep inside the mantle, because convection moves stuff around. And the Earth itself is made of atoms that came from the cloud of dust that created the solar system, which came from a supernova explosion around 5 billion years ago. And all of those atoms were cooked inside that explosion. All the atoms that we see here today, the methane in this vial, the water here, this silicone rock, the only elements that the universe ever produced in the Big Bang were hydrogen and helium. All the other ones were produced in the furnaces of stars and supernova explosions. So anything that isn't hydrogen and helium traces its origin right back to the center of some star, possibly many stars throughout the history of the universe. And when you dial it all the way back to the Big Bang, you can actually trace the origin of every single particle in the universe to a few dozen particles that appeared less than a nanosecond after the Big Bang, when the universe was small enough to hold in the palm of your hand, when it was so small and was the same density everywhere. Tiny little particle fluctuations just popped into existence and left little dents in this otherwise perfectly consistent like ocean of hot plasma. It left little inconsistencies, hot spots and cool spots. And over time, those regions got stretched to intergalactic scales. And that means that those hot spots and cool spots remained and laid the foundation for all the structure we see in the universe today. So those tiny particles left fingerprints that grew to the size of supergalactic clusters that led to like that sort of orchestrated the patterns in which the galaxies formed and ultimately us. And this is where babies come from in the biggest possible sense. So yeah, when you extend this far back enough, all our particles, all our atoms were, you can kind of just trace back to just a couple particles at the beginning of time itself. As opposed to where we're going, this gets a bit more bleak. This is the source of most of my lack of sleep. But where we're going, it doesn't look good no matter how you phrase it. One of my favorite theories of where we could be going is this theory called vacuum decay, which is that space itself may be fundamentally unstable. Something called the Higgs field could spontaneously decay at any moment and induce a expanding sphere of like this sort of new vacuum space that grows at the speed of light and annihilates anything in its wake. And it expands at the speed of light. And the bad news is light also travels at the speed of light. So you have no way to see it coming until it's in contact with your retina, basically, by which point any hope of escape is kind of slim. As opposed to the mainstream ideas of how the universe could end, it's kind of like this cosmic battle between gravity and dark energy. So one that's pulling stuff together, one that's pushing space apart. And if gravity wins, then space gets pulled back together and everything in the universe just has this nice hug at the end, cataclysmically, as everything gets destroyed into a single black hole that consumes all of the universe, in which case we die. The second one is that dark energy wins and pushes space apart exponentially faster, so fast that gravity struggles to keep stuff together at all. So anything that is held together by gravity inevitably loses to the expanding force of dark energy. So at first, galaxy clusters get pulled apart, and then galaxies get pulled apart, and then the stars get pulled apart from each other, and then the planets orbiting those stars get pulled apart, and then even the planets themselves get kind of crumbled apart like dry cookies. And then those little rocks that are left over get pulled apart into molecules, which come apart into atoms, into particles. And at the very end, everything gets spread apart infinitely far apart, and we die. And then the third one is the most pleasant, in which case space just kind of balances out. So dark energy and gravity just kind of tie, and nothing dramatic happens. Space just keeps expanding forever. The stars eventually wither away. They run out of fuel. Cosmos gets darker and darker. Everything just cools toward absolute zero. In which case we also die. But it gives us a lot longer, 100 trillion years, in fact, before all the stars go out. And since starlight is pretty critical to life as we know it, that gives life a window of 100 trillion years. But even after life is gone, and there's a lot that will happen in the meantime, there's still quite a story ahead of us. In around 5 billion years, the sun will run out of fuel and expand and consume the Earth. So we are going to need a lot of sunscreen, or to colonize the galaxy. It's quite probable we will have done that by that point, giving us the benefit of the doubt of more pressing issues this century. And then around 100 trillion times further into the future than the death of our sun, it is believed that protons, one of the fundamental building blocks of all atoms, may have a half-life, which means it is unstable. And if you like your matter, which I personally do, it is not a great thing for your protons to be falling apart. But within a time span of around 10 to the power of 36 years, which is colossally long, it is believed that protons and matter may just begin to fall apart into pure energy and light, leaving basically nothing behind. And around 100 trillion years or times further into the future than that, even black holes, something that for many decades were thought by astronomers to be indestructible, do emit tiny trace amounts of radiation and eventually wither away until there's nothing left but a tiny bit of light. And by light, I mean like so tiny that it doesn't even do it justice to call it light. It's just a few trace photons. That's around 1 million Google years in the future. So 10 to the power of 106 years. And when you take that to be like the shelf life of the universe by the time the last black hole fades away, and when you consider the 100 trillion years of starlight that is the shelf life of life in the universe, then this is the fraction of the universe's lifespan that all of life, including us, has to prosper before everything gets sent to oblivion. So have a good sleep tonight, everyone. This is it, and we are in the cosmos's golden age. So I'm really happy to be able to hang out with you guys in this tiny sliver of time that we have. But basically, this can be seen in an incredibly demoralizing way, but to me, it's actually kind of uplifting because it removes that sort of grandiose need to pursue some sort of grandiose cosmic purpose, and we get to just decide what's meaningful to us on this little planet without the need for anything to be like, I don't know, to me, just knowing that everything is going to just disappear one day really brings us back to the present, because there is no point contemplating this if you want to have a good, happy sleep tonight. So that brings me to the end of this presentation. But I'd like to say, if you want more of this existential crisis-inducing content, for some reason, I have written a book on it, and I would be more than happy to sign you a copy for those here tonight. And there you have it. Thank you so much for having me tonight, and I wish you a great night tonight.
Thank you very much, Nathan.
Thanks, Nathan.
David, you have a question.
That's applause.
Oh, and that too. And that
I have
too.
comments. I've had the book for a few days, and I started off reading it page by page, and it's written very well. But then I started dabbling through it, and a great thing about the book is you open up any page, and there's something fascinating in it. So it's you could consider it a bit of a textbook, because it does have this flow and has all this information in it, but it is written in a way that you don't have to go. It's 200 pages long, but you just go in and pick any one page, and there's going to be something fantastic in it. And I'm enjoying it in the dabbling way.
I'm glad to hear that. Thank you.
And we have 16 copies here for $25 a piece, if anybody is keen.
And I have a pen here.
No, they're all signed. You signed them already.
For names, in case anyone wants it.
Oh, you can put in more, yes.
Lori, you have a question. Lori, we can't hear you.
Thanks, Nathan. It was really nice to see you. I have a photograph from the back of the room where you and Bob are little wee tiny creatures up at the top, and there's a whole waft of people up in front of you. It's really wonderful, and I am happy to say that Nathan is a friend, which is really important. Nathan, tell me about the hardest thing about this book. What was the hardest thing you had to do here? Like, was it like talking with people? Was it getting the first dabble of somebody to do something? Was it finishing the book? What was it that was hard?
My first instinct to respond to that question was sleep, but if I'm to be honest, in other senses, it was probably the corroboration of evidence to make sure that I wasn't just dabbling on like philosophy fandom pages, to make sure that I was actually looking at like credible sources. The research was the longest part, that's for sure. But it was definitely fulfilling and worth it.
I thank you. Yeah.
2 years ago when you were 14.
Yes.
And you did video.
Yeah.
Nathan?
Dorothy has a question.
Yeah, no, kudos for the presentation and the book. I haven't seen the book itself, but it's interesting. I just wanted to put you on to something to think about a little closer to home and extend this actually and search for extraterrestrial, extra solar system life, extraterrestrial life. Is that we know the molecules for life are common and could assemble in a plausible way for life, which needs to be able to reproduce itself, of course, and also be flexible as the planet evolves, the organisms evolve. And there are interesting things known from Earth life, the probable course, and other sources that link specific events early in the formation of our planet that might be interesting to follow up. An intriguing question is that all the RNA is right-handed, or the nucleic acids, that is the curl of the direction of the curl of the molecule, and the amino acids are left-handed. So levodextry and right-handed, sort of like two hands fitting together. Is that essential? How did that happen? Because out in space, both these molecules have been found, and in both spirals, the DNA, the RNAs, the nucleic acids, and the amino acids in space. So were they selected? Is this essential? Could it be the reverse? There are all kinds of intriguing questions to follow up that make our life special. And that informs what to look for on other exoplanets. It's just a thought.
Sure, that's really interesting. I didn't know about the left spiraling and right spiraling amino acids and RNA. There's definitely a lot of like fantastic coincidences in the history of life on Earth that kind of gets into like the anthropic bias and all sorts of like circumstantial observational effects we will see just because we are evolved on a planet that is well suited for life. But I would definitely like to look more into that.
Yeah, as more and more from various sources, but particularly from molecular genetics, it's fascinating, the details of very likely the course of early molecular and organismic evolution that are being proposed based on real data. It's fun to go off and speculate, but these are pretty well reviewed and pretty rigorous and really give us something to think about. But that's, I mean, after all, I know you haven't had a lot of biology yet, so, and other sciences. So kudos, nice job.
Thank you. And I will look into those things mentally written down. Thank you.
Thank you very much, Nathan. I loved the book launch with you and Bob. It was just such a nice combination of question and answer and fun.
Mhm.
Thank you.
All right. Any other questions for Nathan?
Yeah, back here.
Can you define what a credible source is?
Something that has appeared at least, I kind of went with twice, but should be 3 times in a academic journal. I just looked for something that has appeared multiple times in independent scientific journals. I don't know if I have like a one category fits all solution for a credible source, but I definitely made sure that there was corroborating evidence in different publications, if that helps.
Thank you.
Mm-hmm. Right. Randy, would you like to go next?
I'll go next, and I'm going to start with putting on my camera.
Oh, I will stop.
And I have to put my, and can I pin myself so I can make myself big? Pin. Okay, so I just got this like an hour ago. This is for Bill. Anyway, this is the Radio Lab Zoosve t-shirt. But it doesn't have anything that seems to say Zoosve to me. I believe that this is Neptune and going in towards the sun. And so Venus is like very, very small little circle here. You certainly can't see that there's something wibbling back and forth between Mercury and Earth on it. But that's the shirt that you get when you join as a member of the Radio Lab community. But I was very pleased to get the shirt. There we go.
Randy,
but that's not what I'm going to talk about.
Oh, okay.
I invite the people who are here to try to help me figure out what the icons on this are. Okay, so now what I am going to talk about is the auroras, because I remember from 40 years ago when I took a course on atmospheric physics that this came up, but I had to learn it over again. And why would I learn it without also sharing it with you? So I'm also going to just get this. I gotta go chat and turn this off, and then we should have the whole screen. Good. So first of all, this was my favorite picture from Saturday night. That is the Seashelt Inlet. And I had just given a talk to the Sunshine Coast Center of the RASC. And it's a lovely community. They had about 20 people in the room and a couple of people online. And we went out for dinner before, and I was just so impressed with everybody there. And I got to stay with Richard Mitchell, who lives about 200 meters from this spot. And we went down there. As the tide was going up, he had set up his tripod, and he didn't want to move it. And so he actually got wet feet as the tide was coming in. I moved back because I wasn't trying to get a time lapse. But people don't take enough pictures of the aurora with the moon. But of course, that's what I wanted. Anyway, I'm going to talk about geomagnetism. And people say that William Gilbert's book, De Magnete, is the first geophysical text in 1600. And among other things, he had a ball of magnetite fashioned and he looked at the magnetic field on it and he said, how about that? That's exactly what is happening on the Earth. And he said, so it looks like the Earth is just a great big magnet. And indeed, that continues. Here we are 4 centuries later. It is not considered a permanent magnet. Among other things, a permanent magnet never reverses polarity, whereas the Earth's magnetic field, the median is every 100,000 years, the north and south fields switch. And you can't do that with a permanent magnet. It's in fact a fascinating magnetohydrodynamic system 3,000 kilometers below our feet that is producing the geomagnetic field. Topic for another day. But it has the geometry of a bar magnet. What's kind of interesting is that it's the South Pole, which is in the north, because when you have your compass, you call the arrow that's pointing north the North Pole of the compass. And so the North Pole attracts towards the South Pole of another magnet. And so the way that you do that is by saying that this magnet, which is in the middle of the Earth, there we go, is actually south in the north and north in the south. Anyway, the thing is, once you get further away from the Earth, then it is modulated by the solar wind, which isn't just during these big events. There's a continuous flow of ions, a plasma, which is moving up towards the Earth, but we are protected from this solar wind by the Earth's magnetic field. And what happens is you get what's called a bow shock, and most of the ions get swept around the Earth's magnetic field and we don't see them. But sometimes, and about every 11 years, the sun gets very active. Interestingly, it's the same thing about reversal. The sun's magnetic field reverses every 11 years. And this is part of the manifestation of that much faster reversal sequence than we have on Earth. Anyway, this, what is it? Sunspot 3664 is huge. And I've been having lots of fun walking around with my eclipse glasses and showing it to everybody who's willing to try, because it was dead easy to see. It's gone off the edge now, but for the last week, it's been really lovely just looking with your bare eyes, well, with the eclipse glass shielded bare eyes, but you didn't need optics to see this thing. And watching it each day move along to the side. And well, there I am. That's on the boat from Gibson's, looking up at the sun. But what's happening, you don't see it invisible so well, but you sure see it. This is 171 angstroms from the Soho Observatory, and that is 8 times ionized iron puts out this color light. Just crazy that they're able to do something like that. But 3664 is that thing going off the side on the right now, around here. And you can see it's throwing out a whole bunch of stuff. So let's keep going. Oops, keep going. So this is a model, because there aren't spaceships all over the place. Basically, NASA and the European Space Agency have these probes that are able to look at the sun and they see what's happening close by. And then not until you get to L1, the Lagrangian point between the Earth and the sun, is there another probe that can measure when the solar wind comes. So this is a bit of a prediction, but the top is the model of the plasma density. So R squared n per centimeter cubed. I had no idea what those units are, but the thing that I want you to know is when you see lots of color there, that means there's lots of particles coming at the Earth. And I chose this time right at the peak, and you'll see that that is on the 11th. So that's Saturday morning. It's something like 2 o'clock. Yeah. Oh, it says at the top. So subtract 7, and that means Friday night at 24 less 5 at 9 o'clock is when we were at the peak. Cool, eh? Because that's just when the real fireworks were happening here. The bottom is the speed. Okay, so what is happening at that time? And this is something which is a bit counterintuitive. I love to say the solar wind comes, bangs against the magnetosphere, this funny shaped perturbed dipole around the Earth, and some of them sneak into those nodes in the north and south, and they crash against the atmosphere, and that produces the aurora. But that's not the case. For one thing, if that were the case, we would see more in the daytime, or they would measure more in the daytime than in the nighttime. But the aurora oval is actually more a nighttime thing. And what's happening is it's the solar wind is, as well as perturbing the bow, the front of this, it's also perturbing way back in what's called the magnetotail. And what happens is that the magnetic field there is so tenuous that it gets shaken around by the solar wind. And when you move a charge, when you have a charged particle in a moving magnetic field, there is a force on those particles. And in this case, it's mostly electrons. So they're light and they get sped up and they move, they spiral around these lines of force, and they end up coming in towards the atmosphere, right where these lines of force come out of the Earth. Okay, so solar wind is moving in this diagram from left to right, shaking up the magnetic field, accelerating electrons, which are already there. They're Earth's electrons. They're not foreign electrons from the sun. They're part of our atmosphere, and they get brought in to where our atmosphere is dense enough that those electrons then interact with the nitrogen and oxygen and make the light. It's remarkable. Remarkable they figured this out too. So yeah, the auroral oval is more on the night side than on the day side. It's not just that you can see it at night because it's dark, but there's more stuff going on because these are electrons that were accelerated from the magnetotail. Cool, eh? Okay, so Richard in his basement has a little cooler, and in that cooler is a fluxgate magnetometer, and he monitors it. He's a ham operator, so Chris and Jim, you might have talked to him. He says that there's always a BC get-together every evening. Anyway, he's a very avid ham operator, and among other things, he makes these recordings and he puts them online, and you can see how things really got crazy. This is this Pacific time? I bet this is Pacific time, because it's starting well back into the Friday the 10th. Or maybe it's not until we get to here that it really goes crazy. I would imagine he did UT. Anyway, I decided to download the last few days from the observatory, which is up on Observatory Hill. And incidentally, they wanted to put the great big green box on another part of the hill. And a couple of us in NRCan, Natural Resources Canada, complained and said, are you sure that you're not going to affect the observatory, which has been operating up there for 70 years, and you didn't want to destroy their time series? And they looked into it, and then they decided they had to move the box to in front of everybody's windows in the office building. Oopsie, I do have a plugger inner. I'm prepared for this. Anyway, so this is the last week's data, and this is kind of what you get normally, and then this is what happened on Friday night to Saturday. And you can also see why we didn't see anything yesterday. It's just not as big. So now this is the same, but I've just blown up the scale. So you can see that every day there is a big transition from plus to minus around noon. And that's totally normal. This is normal solar activity and the interaction between the geomagnetic field and the solar wind. There was something that happened last Monday, and then woo, all hell broke loose on Saturday. And this is about the same size as 2003, a bit smaller than 1989. But this is like a once in a generation sort of event. And we're still on the rising edge of this solar max. We've got another couple of years of this solar max to watch. So who knows what's going to happen. Anyway, you will see in a lot of the websites the KP scale. And K stands for Kenzeifer, which means characteristic number. And it was defined by Julius Bartels, and people in the geomagnetism world, like me. This book, Chapman and Bartels, 1940, is the beginning of modern geomagnetism. And what Bartels did is he took 13 stations around the world, mostly in Europe, but he took what was available at the time, and each one of them, he's kind of normed them so that the K value from the ones that are higher latitude, you get higher fluctuations, but he's made them so that they're all kind of the same scale, and you average them every 3 hours, and then you get a planetary K scale. That's KP. So you take the Ks from all of the stations, normalize them, average them, and take the logarithm of that, and then you get this KP scale. And they have this going back all the way to 1939. And he also developed what he called his music graph. So what you see here is all the data since January in lines of 27 days. Why 27 days? That's how long it takes for the equator of the sun to go around. And so you can actually see the same sunspot come around and around. You don't so much in this particular graph, but I imagine if 3664 makes it around again, we'll see another good splotch next week. But the numbers go from 0 to 9, and each of these lines, these are for low activity, and then once we get up to 5, then it adds the black bits, and then when you have 9, it even gives something at the bottom. So you can see how different our event this weekend was from anything else that happened before. I think that's pretty cool. And then there's this observation that the sunspots, the number of sunspots, is beautifully correlated with these magnetic disturbances and these geomagnetic impacts on technology. I've been looking to find what impacts happened this weekend, and I see little vague reports, but I haven't seen anybody actually compile if there were any power grids that went down. But we have in NRCan, we have a space weather team, and their job is to inform Hydro-Quebec saying, well, a big one's coming, and then they get their breakers ready so that the lines don't blow up. You might also ask why Hydro-Quebec is the most vulnerable. First of all, they got the longest power lines from James Bay all the way down to Montreal, but it's built on the Canadian Shield. It's an insulator. Usually, the magnetic disturbances is spread out all across the ground, but since the ground underneath these wires are insulating, all of the induced currents go into their power lines. And if you get too much, then it blows the circuit. That's it.
I have a question.
Good.
Your Soho image,
Mhm.
there's a whole bunch of sunspots coming. It looks like
It does. It looks very busy.
it's very busy.
But 3664, I don't know why I've remembered the number, but it's huge compared to normal sunspots. It's not just any old sunspot. And that's, and we know that it's been 21 years since anything like that. And they say it's the size of the Carrington event in 1859. So I don't know much about Carrington, but they say he was doing his daily sketches of the sunspots, and there was a flash in his telescope. He actually saw a flash at that time, and then a day later, then telegraph offices started burning up. So that was kind of the beginning of figuring out that connection between induced currents from the geomagnetic field and the sunspots. So
Oliver has a question.
Well, not a question, but a comment, though. Very, very interesting, and thank you very much. I was looking at the last graph that you showed, and in 1960, there was a big surge. And I can remember walking home with an early girlfriend in high school and looking up at the stars and seeing wonderful aurora in London, Ontario. And now I know why that occurred. It was because there was that surge. So thank you. I remember the girl quite fondly too, but the
I see Bill and Dave.
Yeah, so I was watching that sunspot for days, and I sent a picture to David of 3 days in a row where you can watch it condense, keep its size, but it just became darker and darker. And when I was looking at it in H alpha, I don't think I've ever seen activity around a sunspot like that. You could, it was like it was shimmering.
Oh,
like
yeah.
You shouldn't actually see changes over a short period of time. Like I've seen coronal mass ejections go off where a nothing turned into a little white dot, and then over about 20 minutes it disappeared. And then the next day I'd see reports, and then I'd look on of Aurora, and then I'd look on space weather, and you'd see that there'd been a coronal mass ejection. So I was kind of waiting for it to blow like that because it was just bizarro.
Bill, do you recall? Because on Wednesday when I photographed it, space weather actually showed two sunspots that were actually close. I think it was 3664 and 3665. I think,
or six.
There was actually two of them.
There
or
were two
six
names, and then it turned into one.
Right.
And
right.
and it merged and became just one big spot. So it was really interesting to see the progression of it. And
I just love that you saw that shimmer. That's fantastic observations.
It was strange. And oh, what was I going to say? I completely forgot the other thing that I was going to mention. Oh, I'll think of it later. But that it was just the sunspot was just crazy to watch it change. Yeah.
Dave Payne.
Well, I just want to go back to what you were saying early, Randy, and it also went on to the topic of the scale of things that we were talking about. But just, you were talking about the dynamo inside the Earth creating the magnetic field.
Yeah.
That interacts with the solar wind there to create the aurora. The sun itself is a dynamo magnetic field too, and it reverses poles. So the South Pole becomes a North Pole
every 11 years. And
every
it's
11
interesting,
years.
that's like clockwork, whereas the Earth is completely random.
Yeah, but it's when those poles are shifting that the magnetic field goes haywire on the sun, which is actually made out of liquid metallic hydrogen at the surface. And that's what's causing all these ejections, is when those poles are shifting. So it's just, and you know, further taking the analogy, the sun's magnetic field around us protects us, and the solar winds protects us from a lot of the cosmic radiation and left over from supernova and stuff like that.
That's right. They say that the observation, the science that's still coming out of the Voyager spacecrafts is measuring the magnetopause around the sun. So it's the same thing around the solar system that the magnetopause of the Earth against the solar wind. It's the same sort of physics. So if we define the solar magnetopause as the limit of the solar system, those two spaceships have just recently, like in the last couple of years, passed it.
Oh, okay, cool.
Bill, did you remember what you wanted to say?
I did remember. So
Yay.
you were wondering about power outages and that. Something that before the Aurora showed up here on the Friday night, there's a person that I follow who's a storm chaser, and she was commenting about how the farmers on the prairies were starting to complain that the GPS on their giant tractors was not working anymore.
Excellent.
So it was throwing them off.
As a drone pilot, we have to pay attention to the KP number very closely, and actually the warnings come up on the software we use to fly our craft with, because radio waves, big problem.
Those must be, they must be very, very large fields if the farmers need GPS to get around them.
Yeah, so their lines will be straight, right?
Oh, right.
And all the modern tractors, they're all like automated and everything, and so they can do stuff 24 hours a day. They can just go out and the thing will just go. So they couldn't. They had to shut down because they'd have crooked lines, I guess. Over many, many kilometers, you'd have a pretty big distance that you could be off.
Dave Robinson has a question here.
I have one more observation. Back in the late 70s, working for a municipal engineering firm that had an office in Whitehorse. And they sent me up to look at an exploratory mine at the top of McMillan Pass between Carcross and Norman Wells. This was in the middle of winter, like -40. And I was doing some work at looking some equipment there, and I decided to go out in the middle of the night to see what it was like at -50. And the Aurora was out surrounding me, and it was probably the third best Aurora I've ever seen. But the amazing thing is that's the only time in my life I've ever heard it. I heard the Aurora that night.
You've heard it?
Yeah.
What's it sound like?
I can't remember very well because when I went up to the Arctic with my dad. Yeah, it's
little sizzling, a little zinging.
It's sort of like that, but you have to just be quiet. Obviously, mostly there's not a lot of people around, and yeah, it's just
Friends heard it the other night.
Yeah, it's,
Crackling.
yeah,
Yeah.
it is, the crackling is probably the best way to say it. Yeah.
So I had an observation, which I bet Dorothy can comment on. Is Dorothy still on?
Yeah, she's right there.
Oh, good, yeah. It is mostly a, shades of gray. And I remember at one point, the whole landscape turned purple. But mostly, the pictures that we're seeing are because we've enhanced them electronically. And I remember you talking about it once, that we have a little gate in front of our rods and cones. And if there's not enough light, then the signal doesn't get to the cones. Is that what we're seeing when the Aurora is not giving us color?
Yes, that I think what you're recalling is perhaps my report that was quite excitement for a short time among amateur astronomers, the discovery that one can actually see colors in when very dark sky, and looking at nebulae through telescopes and various shades of gray in great detail by a brief, very brief, was accidental actually. Someone wanted to change the music they were listening to on their phone, and they accidentally lit up as they were at the eyepiece, flashed the bright screen, or even if it were dim screen on, was enough to briefly open the circuits by which the cones and rod input converge on certain cells in the retina. The retina is extremely complicated, and the connections change depending on the level of light and other conditions, and on a circadian rhythm as well. So mostly, unless you get a brief brighter illumination that can activate this very briefly, the connection of rods and cones to those cells that pass the information through the brain and through to the brain and would register color, you're going to see various shades of gray. I'm not sure exactly what you're driving at. Does that make sense?
Exactly, you've reminded me why you talked about it. But so that's the question to the crowd. How many of you saw color on Friday night? Oh, look at all that.
I did.
Yeah.
I definitely did. It was the strongest visual aurora I've ever seen. Because normally you see this kind of brightening, and then you get your camera out, right? But this one I saw just with my eyes. It was very bright.
Lots of pink and orange.
Earlier in the evening when you saw colors, I was out there about 1 or 2, and you'd have to acclimate your eyes to see the colors. But I heard it was really big.
I've seen a very strong aurora with lots of dancing, and the entire sky lit up, and it was beautiful what was going on, but it was nothing but green.
Oh, really? You didn't see any pink?
No, that wasn't the aurora the other night. It was years ago when I was in the UK.
But green is our greatest sensitivity, right? In that green area, right? In our natural vision.
Yeah.
It also depends what level of the atmosphere is being excited.
Yeah.
Oh, okay.
The oxygen is way higher up. The red is 150 miles and higher.
Yeah.
And
okay.
And green is lower down, I believe.
100 to 150 kilometers.
Red, we're not very sensitive to. It's quite true.
Where I noticed the most red is because we could see it. We were at Taylor Beach, where there was quite a party going on, and there was lots of green, the red was often on the fringes as well, although if you put a camera on it, it would be the whole sky was red. But where you could notice it the best is when you looked with a tree silhouette. And then all around the dark black silhouette of the tree, it would be red. It was interesting. So there was these contrast things that could show it better.
Yeah, and actually that is a known visual illusion with your eye. When you put black against something, it changes the characteristics of the color. So you're exactly seeing that for sure.
But I do know it was red because if you put a camera on it, it looked like the trees were on fire.
In fact, I was using this. This is the amazing part of it. I was using my phone actually just to see if stuff was there because I could visually see it on the phone. It doesn't even have to take a picture. You could just scan it with your phone.
That's
know,
not an illusion.
I asked Sherry if she could give a talk, and she's traveling right now, but I hope for a couple of weeks now. She's putting out, if you don't pay attention to her posts at Coastal Cats, they're fantastic. She's very up to date, and she tells, you know, every couple of hours before these events happen, say, be ready. So I hope that she can give us a talk in a couple of weeks.
Yeah, she's a known Aurora hunter here in Victoria.
Just to add an explanation to that contrast, when you have black, the basis for that is removal of inhibition from the cells that underlie the black area, because there's extensive cross inhibition between cells in each layer of the retina, which underlies our ability to pick up movement and get high contrast. And that's a perfect example of that. That's really neat. It's the first time I've heard sort of from outside, not a derived definite setup to show that.
So Dorothy, the first time I had even I think I've noticed it informally, but I learned it formally in a color theory class recently. And they made us actually look at colors against gray, white, and black. And sure enough, that's true. It affects the colors.
Yeah, I had plans to actually get, when we were at the old Astronomy Cafe site, and it would have been possible to set up an illustration we had a screen that hung out a little bit from the wall behind, so that you could set up a real life example of that. I thought it would be fun, but then whatever happened, we end of cafe for the summer, and then COVID, and we moved spots. And
thank you very much. That's really informative. I know as a painter, when you paint, when you put color on paper and on a canvas, and then you put something else beside it, of course, there change occurs. And that's why as painters paint over the whole canvas kind of at the same time. You don't just paint an area and then start and paint another area. Each color is affected by what is around it, what it's touching.
That's cool.
The same is true for painting inside houses, because whatever you choose in the paint store turns out to be different on each of the four walls of the room that you painted in, that you use it in, depending on where the light comes from and where the shade is.
For sure. Dorothy, while we have you, you wanted to extend an invitation.
The Zoom banner is in there.
Anyway, okay, well, this display panel is the electromagnetic spectrum lighting display that originally Sid set up for what was then light pollution, and now we call responsible lighting, good neighbor lighting. And Dave Robinson has supplied the information details for what are good lights, but originally it was set up against walls. So the it's a three Sid got this three panel folding large display. But when we started setting up at fairs and events like Astronomy Day, where it's out in the open, there's the other side, because it's three panels, but each panel has two sides. So there basically is possibility of 6 displays. So somehow I ended up putting up displays, and it's fun. And I wanted to just run through really quickly what's there to entice everybody to come by and look at it, and hopefully get involved in designing it, because I'm not going to be able to and won't be continuing forever keeping these panels up to date. So the central panel of the 3 is history. The right panel is the electromagnetic spectrum, story of our universe, and the left is planetary. And I'm just going to show you briefly, run through quickly. This, I hope you see the whole top of this slide.
Yeah, we can see the whole thing.
Our first part, history of the planet down to when humans started with fire, when emphasizing yellow light. And this is the second version of this. I had it then historically in order, and it was a guest, and the first Astronomy Day that this was set up at the museum. A visitor from, I remember she was from Salt Spring Island, an artist who suggested changing this and going from the top, running arrows down, and people have found this to work, down to the foundations of 17th century foundations of modern astronomy and study of light, and then up through 18th, 19th century of physics, biology, technology, spectrum analysis. 20th century, really a lot of biological and other progress, of course. And then the 21st century, biorhythms arrive, fractured ecosystems. So this has stayed pretty much the same, but this column I've updated several times, and it's something that any of you could do a much better job. But I love, was it Brandy, I think, or someone mentioned the Voyagers. The top, well, the top are the probes and space probes out spanning the electromagnetic spectrum with it, and then coming to more recent ones down Hubble, and I got the James Webb telescope combined with the Gaia, and then Earth-based telescopes. And there's a lot, there are different things that can be done with that. It's reasonably up to date, but it's a lot of fun, and I'm sure others of you could do a great job, better than I, and choose different things. And the whole continuing this theme on both sides of this display, that it's light, electromagnetic spectrum. So this is a planetary one, the top with sun at what atmosphere does to what we actually see, and the 3 natural light cycles. And then these are later things that I've added they could be more, definitely more focused. And I think it would be fun to follow up on what's coming from space from Earth, the data from Earth, life and almost certain conditions, to extend them to the data coming in from potentially habitable exoplanets. So that's just a thought. So, and then those are the three, whoops. And then on the other side, we have the responsible outdoor lighting, a lot more information about the planet and our planet, which is most important to us, and why it's needed. So, as I say, it's an invitation to newcomers and old to come and take a look at it, make suggestions, and possibly get involved in keeping these displays more or less up to date, changing them, because certainly all the subjects are changing rapidly. So that's all I had to say. Stop sharing.
Dorothy, I noticed that you had QR codes to your information. They don't seem to land on anything, so you might want to talk to Joe about maybe updating that, because it would be very useful to be able to look at it, because you have so much detail in the posters. It would be nice if we would be able to zoom in and read each of the pieces.
Yeah, thank you, David. I'll check that. I thought the QR codes that
I just tried it. It does work, except there's nothing on the page, right?
Okay. Well, I'll look into that.
Yeah, check with Joe on it.
Yeah.
Lori, you have a question.
I know that on the back side of the display, there is the 2010 map that we did of the quality lighting survey. And I'm wondering whether or not there's anything that we have got from the survey that was done now 2 years ago
I
that
do.
we can add to like we can actually show the difference between
Yeah,
the two maps.
I do have the summary data. I just did impromptu maps, but I can see what I can do before Saturday if we can get something.
Or just or just sometimes, that is up at different fairs, and I mean, we put it up lots of things, so it doesn't need to be done for Saturday, but I just think it would be a really good thing to have that comparison between the two surveys.
It's on my task list. It's something that Dave Robinson asked me to do from a couple of weeks ago, so it's on my list.
Okay, thanks.
Yeah, thank you, Lori, because I've been attending to talk to Dave about that as well, to provide some update. People ask about that when they look at that map, and that has drawn a lot of interest. So I think it's worthwhile to add a note if we can.
Thank you. Brock, you have some photographs to show.
If there's still time, I could quickly go through them. So I managed to get some shots in my backyard on Friday night. So I thought I'd quickly, can you guys see that?
Yep.
We can.
We actually started by going down, or trying to go down to Island View Beach, but as soon as we rounded the hill and looked down across the highway, we could see just endless line of taillights going all the way down to Island View. So we knew that wasn't a good plan. So we just headed back home and got some pictures from the backyard, but it was pretty vivid. This is from a different direction, but when we mentioned seeing the color with our naked eyes, this particular red area was probably the most standout color that I remember seeing visually, which was looking east. And then, of course, this familiar thing that lots of people have shown, this directly overhead, which was kind of interesting. Another shot of it. So
beautiful.
pretty
It's the
amazing.
Orion Nebula.
Yeah.
Really big.
Yeah,
That's
really
what I kept
close.
thinking when I'd look up at it. It's like, it's the shape of the Orion Nebula.
I kept expecting a TARDIS to come flying out of it or something.
But the shape of it was just so surprising. It was just,
Yeah. It was like,
you know,
what's going on
you
up
looked
there?
and you can't believe what you're seeing.
Yeah. Yeah. It's crazy. Couple
Looks
of
like
the shots.
looks like a bird taking off,
Yeah.
Yeah.
like a dove or something going.
Yeah, it's pretty neat. These are more
Interesting.
like that sort of curtainy kind of looking stuff.
Yeah,
coming
they're more
down
like
from above.
the rays.
Yeah, they're-
Actually, a lot of people have mentioned angels. I don't know if it's just
Okay.
what they want to see, but
Sure.
a lot of angels in some of the shots.
I didn't see angels.
Devils, perhaps.
One interesting graph, I put this plot. This was actually the data from my image collections. I've been shooting some galaxies, and this is the sky background brightness. This first one was the background. So these are these peaks is like dawn or dusk at the end of an evening. And then this was a 60% moon. This was, I guess if this was Friday night, this would have been Thursday night, Wednesday night, Tuesday night, and then Wednesday night, Thursday night, and then this was Friday night, which of course I didn't get any useful data, but you can see how bright Friday night was.
Tuesday night was new moon.
Yeah, that would have been here. And then the next night there was no aurora again. You can see that it was slightly brighter because the moon was getting bigger, I guess, but it wasn't anything like that one night. But it's amazing how much this was a 60% moon. So you can see it's quite a bit brighter. This was April 16th. And then I took quite a break, but then I got back to it. But the brightness was pretty amazing. And then actually the summary of all of this data turned into this picture. So I got this was Messier 91. Nice spiral, barred spiral.
Were you able to photograph during Friday night?
No, this data was just garbage.
Okay.
You couldn't see anything. So, and then I also had been working on another shot. This was taken way back in April, but I finally processed it. So this is Messier 95 and 96. But some more beautiful spiral galaxies. And that's all I got.
Brock, I have a question for you.
Sure.
When you said that you saw the red that was very dominant, did you literally see red?
Oh yeah.
Oh,
Yeah,
okay.
this here looking east, that was distinctly red, just with the naked eye, really quite red. The most vivid color I remember from that night was that particular area above that tree line. And maybe it was part of that issue of it being near the black of the trees. That might have helped. So
What time was that, Brock?
11, probably 11 to 11:15 maybe. We got back from our attempt to go to Island View at about 10:30 and went in the backyard, and at first I thought it was a band of cloud, and I was like, what is that, a cloud? And then as I stared at it, I was like, no, that's not a cloud.
Yeah.
And then it started to really just come to life just after that, and it was like, wow, this is amazing. So
Yeah, my
late.
peak was 10:53.
Yeah, that was 11:09 p.m. because I have the timestamp on my photograph, which I took at that moment.
Yeah, so
And
around that time,
it
11.
it transitioned very quickly from the normal view, you might say, to
Yeah.
the red, and then back quite quickly.
Yeah.
Well, I woke up at 2 and went out and thought, if it's really going to be this bright, I can see it but from our deck. And I think it was just too late.
It was still visible in my cul-de-sac at 2. And it was just unbelievably
dark,
bright.
though.
Well, you know, like even in my light polluted area, like I think I'm like a 15 or a 16 on the meter, and I could see it with my eyes.
I should get that image background brightness data. I can download it to Excel and I could actually plot, because that brightness on that plot would indicate how strong the aurora was through the night. I just
Mhm.
have to put the times
Brock,
against it.
Brock, do you purposefully image a blank area of the sky? Is that what you do, or?
No, the
What?
software just figures out the background and
Oh,
tells you
for
how
whatever
bright it
you're
is.
you're imaging.
It's just to help narrow down your like if you're trying to triage the photos and throw away the crap, you just get rid of the ones with the bright background and the ones with fat stars and the ones with not very many stars. And
Marjie.
Yes.
Before we go, I would like to show a slovenly way to monitor the aurora. Could I share it?
Sounds intriguing.
Exactly.
I was wondering if there are any announcements before we.
Oh yes.
Right.
Very, very important. We've delayed this so often. I think people are confused now, but the getting started in astronomy SIG, the beginner SIG, is actually Wednesday night. Wednesday night at 7:30. So everybody remember that.
And there is the final meeting for International Astronomy Day tomorrow evening, and I put the link in the invite for today's Astro Cafe.
I won't be there, but I'm ready.
You're awesome, Bill. Okay, and I'm really keen to see what Reg is going to say.
Okay, I'll just try and share the screen here. The DAO has a thing called the DAO Sky Camera, and about 9 in the morning, the movie from the previous night is available. And so what I did was I did a screen capture of it, and I just want to play a part of the movie, and we'll go from here. And that's the aurora.
Wow. Oh my, look at that.
Every 4 minutes.
Wow. And you can see the stars going by. That's lovely.
It actually had a stirring pattern. I haven't really looked at all my feed yet, but I was trying to determine whether there was a direction that it was kind of moving. And it looked like it was almost like in a circular motion, like a vortex.
So that's a pretty useful thing if you're imaging at night, to go and see that all sky camera in case some high cloud wanders across your area overnight. But it works pretty good for auroras as well. Just keep that in mind.
How much lead does it give you, Reg? Like it shows you the last hour or last 2 hours?
What, that was all night. It's 24-hour all sky camera.
Oh, so it's constantly imaging.
Yeah, day and so I just showed you the interesting segment.
Does it archive?
No, you have to. I have to do a screen capture after 9 a.m. on the following morning, and it's certainly worthwhile doing if you're doing astrophotography, so you have an idea if there's any high cloud moving in it. Not, it's really a very useful thing. So that's at the DAO.
Thank you. And the last word to Lori.
I just wanted to say on Friday night there was a quite a big crowd up for a cruise tour, and we were kind of deliberately saying, well, we don't know whether there'll be any aurora up, and we didn't really say anything, but first thing off the bus that the people were saying is, are we going to see aurora tonight? And so they did, and they were just absolutely gobsmacked with what they saw. And they went away really happy. And Amy Rawson took a picture of the aurora with the dome with the dome, and it turned out really nicely. So I haven't got it up, but I should show you sometime, because it really was quite something. So that was really nice just to be able to do that. And at last, everybody come to Astronomy Day on Saturday during the day at the museum and up at nighttime. That's all. Thanks.
One quick thing regarding cruise ships. We watched one leave when we were at Taylor Beach. We were watching it leave. I was wondering if they'd been up at the DAO, but probably not. But they stopped out in the ocean. they were going and then it didn't go. It was really weird. Like, and then I thought, I wonder if they have stopped to watch the aurora or if it was screwing up their GPS. Thinking now it could have been screwing up their GPS and it wouldn't have been safe for them to travel too much. Because
maybe both.
They would have we could see them out past like William Head, and usually then they disappear. But it just sat there for about an hour at least. And by the time we left, it was still sitting there and it should have been gone. It was odd.
Thank you, everyone, for attending and for wonderful presentations and sharing. So good night for tonight, and we'll see you next week.
We'll see you Saturday.
We'll see you Saturday.
Saturday, nothing. Next Monday is Victoria Day.
Oh, yes, right.
Last of the season. And Brock, you're the host, I believe. Very good.
See you Saturday.
Summer off.
Good night.